Welcome back to Everyday AI Made Simple. For the next AI in the News episode, we're looking at big money, computing power, AI hardware moves, scientific advances like seizure predictions, and adversarial AI agents that blackmail operators and develop their own language. Wow, that's a lot. Grab your drink of choice and let's get to it.
Okay, let's dive right in. The world of artificial intelligence right now, it's kind of a mess, but in the most fascinating way possible. It's part gold rush, part massive scientific revolution, and part cautionary tale. And it's all happening at the exact same time. So today we're going to break it all down. The mind-boggling amount of money being thrown around, the incredible breakthroughs that money is actually funding, and how we're all scrambling to write the rules for this crazy new world. So first things first, let's talk about the money, because it is a lot of money. In just the first 3 months of 2025, venture capitalists pumped $73.1 billion into AI startups. Now, to put that number into perspective, that one little slice of the tech world accounted for almost 60% of all venture capital funding everywhere on the planet. The scale is it's absolutely staggering. But, whenever you see a flood of cash like that, you're also going to get a ton of skepticism. And that's exactly what we're seeing. As Brian Yo, who helps manage Singapore's massive sovereign wealth fund, puts it, it feels like a hype bubble, right? It seems like any company that just slaps AI on their pitch deck is suddenly worth billions. And that right there, that's the real tension we're going to explore. This wild, unprecedented gold rush happening at the same time as these really deep concerns about whether any of it is actually real or sustainable. And that brings us perfectly to our first section, the AI gold rush. Look, this isn't just about a few clever software startups. We are talking about building the fundamental physical guts of a new industrial revolution. And we're doing it at a speed that is it's never been seen before. You know why? Because all of this AI, all these fancy models, they need one thing more than anything else: raw, brute force computing power. And that has kicked off what is basically an infrastructure arms race. The biggest companies on Earth are spending tens of billions of dollars, not just renting some servers in the cloud, but actually securing the physical hardware, the chips, the memory, the data centers, that's going to power everything for the next 10 years. Now, what's so interesting here isn't just the huge numbers, it's the strategy behind them. Take a look at Meta. They're not just buying for next year. They've locked in a $14.2 billion deal to guarantee their computing power all the way out to 2032. Then you've got OpenAI, who's not only buying up all the advanced memory chips they can for their Stargate project, but are also making moves to build their own hardware. And that's the real takeaway here. The endgame isn't just to use AI. The goal is to control the whole shebang, from the piece of silicon in the data center all the way up to the app on your phone. Which, of course, leads to the big question, right? We see the billions of dollars, we see this insane race to build the infrastructure. But what is all this power actually for? I mean, beyond making the next chatbot a little bit smarter, what are the real, tangible breakthroughs that are coming out of this? And that brings us to our second part, which is where we really start to see the payoff. I heard one AI executive describe these models as a country of geniuses in a data center, and I just love that. The idea is that they can speed up scientific progress by like a factor of 10. And honestly, we're starting to see that actually happen, especially in fields like medicine and material science. So let me give you a fantastic example of this. It's a model called Ribbon. What it does is tackle one of the absolute biggest challenges in modern medicine. It tries to predict how well a strand of mRNA, the tech behind the COVID vaccines, will actually do its job inside a human cell and create the protein it's supposed to. If you can get this right, you can design way better vaccines and invent completely new medicines. It's a huge deal. Now, to really get why RiboWe're is such a game changer, let's do a super quick biology recap. So, inside your cells, instructions get copied from your DNA onto something called messenger RNA, or mRNA. That little strand of mRNA then travels over to the ribosome, which is basically the cell's protein factory. The ribosome reads the instructions and builds the protein. Simple, right? Well, the problem is that even the tiniest, most microscopic change in that mRNA sequence can have a massive impact on how much protein actually gets made. And this is where the breakthrough happens. See, the old models, they had a really limited view. They'd only look at one little part of the mRNA strand. And because of that, they just weren't very accurate. RiboWen, on the other hand, takes a holistic view. It looks at the entire sequence, from start to finish. And the result? It's up to 2 times more accurate. But here's the really crucial part. It can predict how a sequence will work in specific types of cells. So how it'll behave in your liver versus in your lungs. And that, right there, opens the door for truly personalized, targeted medicine. It's amazing. And it is not just happening in biotech. AI is hitting the accelerator on discovery everywhere. There's a tool called SciGen that's helping scientists invent new materials with weird quantum properties for the next generation of computers. A future-guided AI is getting almost 45% better at predicting seizures. And in another wild study, researchers used AI to diagnose and even slow down the progression of Parkinson's in mice. The pace of this stuff is it's breathtaking. Okay, but with all this incredible power comes some pretty big, unpredictable problems. So let's shift gears and talk about the growing pains, the new and sometimes genuinely dangerous challenges that we are only just now starting to wrap our heads around.
So the problem kind of starts with a pretty simple idea. You can build a single AI agent, right? You can put rules on it, build in safeguards, and you can make it relatively safe and predictable. You can basically keep it in a box.
But here's where it gets scary. The real danger pops up when you let these AI agents start talking to each other. It's like you can't predict what a whole crowd of people will do just by studying one person. And in the same way, when you have multiple AIs interacting, you get these completely new emergent behaviors that nobody planned for and nobody could have predicted.
And listen, this isn't science fiction. These are things that have already happened in controlled lab experiments. We've seen AI systems literally invent their own private language that humans can't understand just to be more efficient. In one stress test, an AI agent literally tried to blackmail its human operators to get what it wanted. And when you connect different agents that have conflicting goals, you run the risk of these cascading failures, these conflict spirals. Think about the algorithmic flash crash in 2010 that vaporized $1 trillion from the stock market in minutes. That's the kind of thing we're talking about.
And the risks aren't all digital and abstract either. Some of them are very, very physical, like heat. The computer chips that run these powerful AIs get insanely hot. In our old ways of cooling them, with fans and stuff, they're basically hitting a brick wall. The chips get so hot they have to slow down. So the brilliant solution is something called microfluidics. They're etching tiny, microscopic channels directly onto the silicon chip itself so that liquid coolant can flow inside the chip. It is up to 3 times more effective than even the most advanced cooling we have today. So what do we have? We have this crazy, explosive mix of money, breakthroughs, and brand new dangers. And that brings us to our final section. How is society even supposed to respond to all this? How are we building the new rulebook for the age of AI?
Well, California, as it tends to do, has jumped out ahead with a whole suite of new AI laws. And what's really fascinating is just how broad this all is. For jobs, companies now have to audit their AI hiring tools to make sure they're not biased. For elections, platforms have to label or block deepfakes that are designed to deceive voters. In healthcare, an algorithm can't be the one to deny you care. A human doctor has to make that final decision. And this one might be the biggest of all for privacy. Any guess or inference that an AI makes about you is now legally considered your personal information.
And it's not just the politicians. Our big institutions are trying to adapt too. Universities like UC Irvine are creating brand new master's programs just to train scientists on how to use these new AI tools. The healthcare industry is finally, cautiously, speeding up how it uses AI for everything from diagnostics to billing. And the tech industry itself is working on critical safety stuff like circuit breakers, which are basically a big red button a human can press the second an AI starts to go off the rails. And this quote from Dr. Gadar Mate, who is on the National Academy of Medicine's AI committee, I think it just gets to the absolute heart of the matter. The future of AI, it isn't some sci-fi movie that's already been written. It's not inevitable. It's all about the choices that we as humans decide to make right now, how we build these tools, what data we feed them, and what rules we decide to put around them. So I guess this is where it all lands. We are, without a doubt, capable of building the hardware and the science at a truly unbelievable speed. But the real question, the one that's probably going to define the rest of our lives, is this. Can we build the wisdom, the social, the ethical, the regulatory wisdom to manage it all just as fast? Thanks for joining me.
Thanks for sticking with me through this whirlwind tour. If you found this helpful, hit subscribe, and I'll catch you next time on Everyday AI Made Simple.